I'm good.
So what are we doing tonight? What are we covering?
I think cosine, tangent, and sine, and then also I think trigonometry, and then geometric mean. I think is something else I need to go over.
Okay.
And I think that's all. I'll see if there's anything else.
Let's talk about trig, because trig is going to be the most important for you. You know what this means?
Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent.
Okay. Do you have some specific trig problems that you can give me?
Check. Okay. So let's see.
I know that every geometry student gets some trig, but
Yeah.
I don't know exactly how much. So you need to direct me on as to what kind of trig they've covered so far. I'm pleased that you know SOHCAHTOA. That'll take you a long way. In other words, that's really excellent. But there's a lot more trig beyond that.
Yeah, I have a few problems
Trig is
here.
actually a full semester course that you will take as a full semester course, probably in a couple years.
Okay. Yeah, so I found one. So if there's a right triangle and the opposite side is 29, and then the angle of elevation is 47, what is the hypotenuse?
Is that what you meant?
Yes.
Okay. So the way to solve these is to start with the trig function. We're trying to solve for the hypotenuse.
Yeah.
What trig function is going to include 47, 29, and h?
Sine.
Okay. So the sine of what? Complete that.
The sine of 47 is equal to 29 over h.
Perfect. Which means h is equal to 29 divided by the sine of 47. Now, what kind of calculator do you have, Jonathan?
I think it's one of the standard ones, but grab it.
Can you get sine? Can you figure out sine of 47?
Yes, I can.
Okay. Go ahead and do that and come up with an answer.
Okay, so it is, so the sine of 47.
Do 29 first, divided by the sine of 47.
Wait.
Because the sine of 47 is the same, it's a constant. It's always that number.
Yes.
And you're going to get it from your calculator, so you want to divide?
Yeah, and so that would be 39.6.
Okay. Were there instructions as to how many decimal places you should round it off to?
No.
Okay.
There was.
We'll just call it 39.6.
Okay.
Now, Does that make sense? Let's ask that question first.
Mm-hmm.
Yes, the hypotenuse is always the longest side of a right triangle. So had this come out to be less than 29, we'd have known we had a mistake.
Okay.
Okay. Now, just for the heck of it, tell me what that side is. X. What trig function is going to tell me what that side is?
It would be tangent opposite over adjacent. So then it would be 29 over...
Tangent of what? We always take trig functions of angles.
The tangent of 47
Okay.
is equal to 29 over x.
Okay. And I trust you can solve that. Because that's just a number that you're going to get out of your calculator. Okay. Now, have you dealt with radians yet or just degrees?
Just degrees.
Okay. So your calculator is always in degree mode at this time.
Yes.
When you take a full trig course, they will introduce you to an alternative way of defining angles, and they will be in radians, not degrees. And the most important thing you can do is just make sure your calculator is in radians, if that's what you want it to be. If you want it to be in degrees, make sure it's in degrees. So know what your calculator mode is.
Yeah.
If it's a TI-83 or a TI-84, then it's really...
a 30, I think, yeah.
Yeah, well, then there's a hit mode or whatever that key is, and it will let you specify whether you're in degrees or radians. You will probably be in degrees for the next 2 years. You probably won't get radians until you actually take a pre-calc trig course.
Okay.
Okay? What else do you have? You so far you seem like you're in pretty good shape here.
Okay.
Can you verbalize another one? If another problem that you want to do can't be verbalized, you can take a picture of it and send it to me.
Okay, yeah, I found another one. So there's a right triangle. But it's like, so, oh wait, no, it's two right triangles put together. So it's like, so if you were to put, yeah, so if you put, yeah, it's a right triangle and then.
Like that or like this?
Like that.
Okay. Whenever geometry frequently requires you to send me a picture, just because it's so hard to verbalize.
Okay.
What can you tell me about that right triangle, other than those are right angles?
It's got an altitude of 20, and one of its parts on the part on the left side has a measurement of 50, and so I have to find the
50, 5-0?
No, not 50, 5. Yeah, 5.
Is it that measurement?
Yes.
Okay. What else?
And then x. Then the rest of the sides. So part 2 is x, and then the rest of the other two sides are y and z. And so I have to find what those are.
So that's x.
Yes.
That's y.
Yep.
And that's z.
Yes.
Okay. So what we need is trig functions to figure out what the rest are.
Okay.
We have to figure out what x, y, and z are, correct?
Mm-hmm.
Okay. What's y equal to?
So y is equal to 20 squared plus 5 squared.
It's actually the square root of that.
Oh, yeah.
Anytime you're solving a right triangle, the answer always begins with square root of.
Okay.
Now, sometimes that can be a whole number, but it still begins with square root of, and it's worth memorizing that.
Yes.
Okay, so that is the square root of 425? No. 20 squared is 400 plus 25? Yeah.
Yes.
Okay. Can we simplify that? Back to your algebra days.
Yes, we can.
To what?
First
of all, what does it factor into?
It factors into 5 and
About 25 is one of the factors of 425.
25, and then I think, would that be all, or is there one more?
Well, when you are simplifying radicals like this, what you're trying to do is factor it. Okay, you're factoring the number 425. And you want one of the factors to be a big perfect square number. Well, turns out that both of them are perfect square numbers. So that's 5 times 3. That's 15. What am I doing wrong here? I know what I'm doing wrong. None of that's right. What's 425 divided by 25?
17? Would it be? No, not. It would be 17.
So that becomes 5 root 17.
Yes.
That is what z, or that is what y is. 5 root 17.
Mm-hmm.
Okay, now this is frequently the way geometry problems progress, is that you have to solve one thing before you can solve another.
Mm-hmm.
Well, we've solved for all 3 sides of the left triangle.
Mm-hmm.
Now the question is, how do we solve the right triangle? This one right here.
Okay. So, would you try to solve for geometric mean of part 2, which would be x?
Well, we don't know any angles here, do we? At least not yet.
Wait, on the model, it does have the top angle. Like combined, it does say that it forms a right angle.
This is a right angle right there?
Yes.
Okay, that's going to help a lot. Because we can solve for that angle.
Mm-hmm.
And once we solve for that angle, we'll know what this angle is. Once we know what that second angle is, then we'll be able to solve for x and z.
Okay.
So let's first of all solve for that left angle. What trig function is going to let me solve for that?
It could be opposite over adjacent.
Okay, so give me an equation.
So the tangent of that angle, or maybe angle A, is equal to 5 over 20.
Now, what's A equal to? How do you get it, first of all?
So then it would become A would be would equal 1/4, or no?
The
Oh, yeah.
inverse tangent of 1/4. Okay? Here, let me tell you something. I want you to remember it. You always take trig functions of angles to get ratios. You always take inverse trig functions of ratios to get angles. So if
Okay.
you're solving for an angle, you have to have the inverse trig function. If you're solving for a side, you use the trig function.
Okay.
Okay? Or in this case, we just use the Pythagorean theorem. But nonetheless, we solved for y. And now, if we can solve for angle A, we'll know what angle B is. And once we know what angle B is, then we can use more trig functions to solve for x and z.
Okay.
So in your calculator, look up inverse tangent of 1/4. Or inverse tangent of 0.25. Do you know how to do that on your calculator?
Yeah. Would that be 14 or 3.5?
I'm not checking these on my calculator, so I'm kind of dependent on you.
Okay. So I'll double check that. So.
Double check it. Do inverse tangent of 0.25.
Okay. Yes, so I'm getting 14 right now. That's
All right. I'm just going to round it off to degrees. I'm not going to deal with these tenths and hundredths.
Okay.
Just for simplification. So what is angle B?
Angle B is,
In other words, the fact that I know that this angle is 90 degrees now allows me to figure out angle B.
angle B would be 76.
Now, give me an equation, that's 76 degrees, that allows me to solve for x.
Okay, so x.
Hold
So
on. When you come up with an equation, always start with your trig function.
Okay.
So figure out which trig function you're going to use, and then
Yes.
start with that.
So the tangent of 76
Okay.
is equal to x over 20.
Which means x equals 20 times tangent of 76. Go ahead and give me that.
Okay. That would be 80.
How much?
80.
80? 20 times the tan of 76.
20 tangent. Yes, that's what I keep getting.
Okay. All right. That actually makes some sense. And now give me an equation to solve for z.
Okay. So 80 squared.
Hold on.
Plus.
Let's use trig, not Pythagorean theorem.
So you could do the sine of 76 is equal to 80 over z.
Perfect. When you solve that equation, what do you get for z? Z is going to be 80 divided by the sine of 76. What do you get?
80 divided by, I get 82.4, but you could probably just say round it down to 80.
Same, 80?
No, not 80, 82. 82.
82? Okay. Would have been surprised if it would have been exactly 80. Okay,
Yeah.
so we solved for all three unknowns.
Mhm.
And we used a combination of the Pythagorean theorem,
Mhm.
inverse tangent, sine, and tangent. So we used a lot of geometry and trigonometry on that problem.
Okay.
All right. If you have a problem that's that complex, it's probably easier if you take a picture of it and send it to my email address.
Okay.
Just so, I don't get mixed up in the translation.
Okay.
And in general, I would say that geometry, above all other math subjects, are the most difficult to verbalize. So in the future, if you take your geometry problems, take a picture of them, send it to my email address before our session, that's going to
Okay.
work the best. Okay? It's just too hard to verbalize a lot of geometry problems. You actually
Okay.
did a pretty good job here on this one. I'm assuming I wrote that in the way you intended. But
Yeah, that looks
yeah,
exactly
it
like.
would have been much easier to do had you sent me a picture. Now,
Okay.
do you have my email address?
Yes, I do.
Okay. It's make sure you send it not to David at Digital Math Tutor, but David Cowan 1949 at gmail.com.
Okay.
That gets to me immediately, and do not attach more than one file per email. If you
Mhm.
attach like 5 files, it'll take 20 minutes to get to me.
Okay.
Whereas if you attach one file, it takes like 30 seconds to get to me.
Okay.
If you're using an iPhone, attach it as a large image file. Don't embed it, attach it.
Okay.
And let me know when it says file sent on your end.
Okay.
Because it definitely will not be received by me until it says file sent on your end. And it generally takes just a couple of seconds.
Okay. 1 second. I'm taking a photo right now, so.
Okay. This technology is great. What kind of phone? Do you have an iPhone or is it like Samsung?
It's an iPhone 5S.
Okay. I don't actually have an iPhone myself, but I've dealt with so many students that do that I know you have to attach it as either a large image or actual size also works,
Okay.
but not small image. Small image, I will not be able to read. The
Okay.
resolution won't be good enough. But actual size or large image will produce a beautiful quality picture.
Okay.
As long as you hold the camera steady.
Sending it right now.
Okay.
So I just sent it.
Does it say file sent? It really isn't whether you sent it or not, it's whether your phone says file sent. Because sometimes it can take a while to send that file. Ah,
Okay.
got it. There it is. Okay. Let's see if I can download this. yeah, okay. I can download it, which means I can manipulate it. In other words, rotate it if I have to, enlarge it. Let's enlarge that a little bit. So it looks like that was the one we just did. That looks pretty familiar. That's kind of the picture I drew.
Mm-hmm. It was the one below it, though, so it was number 4.
Let's talk about geometric mean for a moment.
Okay.
If I say 5, oops, hold on a second. Geometric mean has a very specific definition. And it does apply to geometry, but it's actually more pertinent to algebra.
Okay.
In other words, that's pretty much the definition of geometric mean.
Okay.
When the denominator of the left side has to equal the numerator of the right side.
Mm-hmm.
Well, how do I solve for that?
So, would you multiply?
Cross multiply.
Cross multiply 2 times 8, x times x, and then do x squared is equal to
Okay,
16.
now solve that.
So 16, the square root of 16 is 4, so x would equal 4.
Okay. And in actuality, in terms of algebra, it's plus or minus 4. In other words, get in the habit of whenever you're solving an equation by taking the square root of both sides, always begin your answer with the words plus or minus.
Okay.
The problem is not the problem, but with geometry, you always throw out the minus because there's no such thing as a minus dimension.
Mm-hmm.
So the only dimension when you have these geometric mean problems is the positive answer. In other words, if I substitute 4 for x, that stays an equation. And that is the only number. And 4 is called the geometric mean.
Okay.
Okay. And let's see what its applications are for geometry here. Let's see. What have we done? What have we not done?
So we did number 4, and number 1.
Okay. So do we need to do 1, 2, and 3?
I think I had it. So because US would be the geometric mean between RS and ST.
Yeah, that's a peculiar property of geometry, is that whenever that angle U is a right angle, then you have that geometric mean.
Okay.
That's almost coincidental. In other words, that's completely different than the algebraic way I just explained it. Okay? But it turns out when you have a right triangle, or actually you have a bunch of right triangles here, right? In other words, when this is a right triangle, and that is a right triangle, and that is a right triangle, then one of those sides, that one, is the geometric mean.
Okay.
Okay? Just happens that that's the case. That really is almost accidental. It's just something you need to memorize.
Uh-huh.
Okay. So, let's see. We want to work with number 5?
Yeah.
Okay. It's very difficult for me to follow your work here.
Okay. So I think I could.
Well, let me talk about that for a second. Because that's very important for your teacher. Your teacher has to be able to follow your work.
Okay.
If it's all over the place, it's much harder to follow.
Yes.
Okay? If it's organized and you have step 1, step 2, step 3, step 4, she can follow. Is it a she or a he?
That's a she.
She can follow it a lot easier. And you will grade better.
Yeah.
As opposed, if you have it spread all over the place like this, I really can't follow this. I'm a math tutor for 10 years and I can't follow this. Okay? So make sure you can follow it. Now what we're going to do, I'm going to show you exactly how I would have written your work.
Okay.
Okay? And you want to try to do this when you're doing problems like this, just so your teacher can follow it.
Okay.
Now, let's have a look at this. Again, we have 3 right triangles.
Okay.
So I know that that distance is the geometric mean, correct? Hold on a moment. Let me look at this a little bit more. All right, let's start with the first thing. When we look at, forget geometric mean. We don't need it. What can we solve for immediately?
We could solve for z.
Correct. Let's do it. Always do that. What is z equal to?
Z. So you could do z is equal to 18.
Oh,
Z
hold on.
squared.
Always begin your answer with square root of.
Okay.
Of what?
So z is equal to square root of 18 squared minus 6 squared.
Plus.
Oh, plus.
No, I'm sorry. My mistake. It is minus. Because we're solving for a short side of a right triangle. It's the hypotenuse squared minus the other short side squared. Okay. Can you give me a number for that? Round it off to the nearest whole number.
So it would be 288, and that square root would be about 17.
17. First of all, is that okay? Is that too big a number or too small a number?
It's not too small and not too big.
Yeah, it's got to be smaller than 18 because the hypotenuse is always the longest side of a triangle. So as long as it's smaller than 18, it's reasonable.
Okay.
All right, now let's look at what we have. There's a couple of ways we can do this problem. One is by using trig functions. The other is by using the geometric mean. I suspect that they want you to use what? Which one?
The geometric mean.
Okay, so give me a equation.
So it could be, let's see, it would be, so 18 over 6 is equal to 6 over x.
Is that correct?
Let's see. I have it. I have the equation that is needed written down.
When you have three right triangles, tell me the equation, the general equation for those three right triangles. I'm going to erase what you wrote just because I'm not sure of it.
Okay.
Give me the general equation. In other words, which is the geometric mean? Which variable?
Okay, so what I have would be so to find the geometric mean would be y, right? Or
I think so. So I
okay.
think y has to be in the denominator and it has to be in the numerator up here. So
Okay, so
what's the rest of it?
so well, what I have written down in my notes, you need x and w to solve for y, but to solve for x, you could use 18 and 6, or to solve that, and then to solve for w, you can use 17 and 18.
Hold on one second. I want to make sure I don't give you wrong information. Geometric mean is one of those things that they teach you in geometry, but then you never have to know it again. Seriously. So I get it about once a year from students. I have to look it up. All right. In this triangle, according to my book, first of all, do you have a book?
No, I do not this semester.
That's all right. In this triangle, what it is telling me in my book is that BDW over the geometric mean, which is y, has to equal y over x. Okay? In other words, what we know about the geometric mean is it's always the same variable in the denominator on the left as it is in the numerator on the right.
Okay.
And in the numerator on the left, we use the short side of this right triangle. And then the denominator on the right, we use the long side of the other triangle.
Yeah.
Okay, so if we fill in everything, what do we have? W, let's see. Do we know anything? Hold on a second. We don't know W yet. So we have W over Y. We don't know Y yet. Equals Y over X, and we don't know X yet. So using the geometric mean is going to be difficult. I don't see how we're going to be able to do it using the geometric mean. There may be a way, but I'm not seeing it. Hold on a second. Aha. There's a lot of variations of this. We know that much. the variations of the geometric mean are x plus w divided by the geometric mean, which is always y. It's always that vertical, equals the vertical divided by w. Now that makes it a little bit easier, I think. So if I cross multiply here, I have wx plus w squared equals y squared. And we're trying to solve for y. And hold on. All right, let's take a third definition of geometric mean, which is that x plus w divided by the geometric mean, divided by not the geometric mean, divided by the hypotenuse, z, equals the hypotenuse z over x. So this might be our best equation to solve for stuff.
Okay.
Because we know what z is, and we know what x plus w is. X plus w is 18. Z is 17. Well, that's 17. That means we can solve for x, right? In other words, when you have an equation where you only have one variable, you can always solve for it.
Okay.
What is that? What's x equal to?
So x is equal to, let's see, so x is equal to 17, the square
17
root
squared divided by 18.
equal to 16.
16?
Yeah, just about.
Round it off.
Yeah.
Okay. So that's equal to 16. Now what's w equal to?
2.
Now that should, we've solved for x, w, and z. Y is a piece of cake. What's y equal to?
Y is equal to,
What's your answer always got to start with? The words?
the square root of 32, the square root of 6 minus, 36 minus 4.
That's what y is.
Okay.
Okay. Now, I didn't exactly do that in the way I wanted to. I wanted to do it in a nice, organized, formatted way where your teacher could understand exactly what you were doing. Unfortunately, there are 3 different equations that involve the mean, the geometric mean, and I had to find the right one. The first 2 that I used didn't really allow me to calculate much, but the third one that I used did. It allowed me to solve for x and then w and then y.
Yes.
Notice your answer here can be simplified. Square root of 8 is the square root of 4 times the square root of 2. Square root of 4 becomes 2, so that's actually the same as my answer.
Okay.
Only it's fully simplified. This answer up here cannot be right because I'm looking at a square root of 4 and I know that is 2. So it's 2 times 8.
Yeah.
Okay. Same thing for z. In other words, don't give your answers in radicals that can be reduced to a whole number.
Okay.
It's one thing, square root of 5. You leave that as it is. But if I have square root of 9, I don't leave it as that. I leave it as 3. If I have square root of 16, that's equal to 4. So if it is a whole number, always reduce it to that whole number. Never leave it. In other words, that's kind of the definition of when it's simplified and when it is not. Is if you can reduce it, do so. Always. Okay. Well, I think we killed that problem. What else do we have? I think that's everything on this page. Did you send me a second page?
Let's see. There might be more on that page. I think. Yeah, there's actually a problem 6, 7, 8, 9, and 10 on the right side of the page.
Ah, my apologies. I had blown it up so much that I couldn't see those problems. All right. So give me the general formula for what x is on 6.
So x is equal to the square root of 16 squared plus 22 squared.
All right. What's that number?
That would be 740.
Now, I want you to look at that triangle. Does that answer make sense?
No.
Okay. What did we do wrong?
Well, so 740, I gave you the,
It's the square root of 740.
Yes, so if we were to do that, then
Don't forget to take the square root of these.
yeah. 27.2 if you were to do it in, if you were to the square root decimals, but simplified, I was not sure, so I just wrote square root of 740.
That's fine. Square root of that number is fine. Just make sure that you don't put a number down there that does not make sense. A number over 700 does not make sense. You're never going to find a right triangle that has sides of 16, 22, and 700. In other words, this size has to be a number that's relatively close to 22 and 16.
Yeah.
So, hold on a second. Let me make sure that it is worth memorizing how to solve these right triangles directly, not indirectly. By indirectly, I mean don't go back. Hold on a second. I got to do this differently. Don't go back to the Pythagorean Theorem every time.
Okay.
You don't need to. And the reason you don't want to is because it takes a lot longer. Okay? Yeah. In other words, here's what you want to remember. Just a second. And this is very rare that I recommend this. Usually I recommend people memorize the formulas. C squared equals A squared plus B squared. That is the Pythagorean theorem.
Yeah.
C is the hypotenuse. And you can always start there. But you're going to have to solve about 500 of these over the next 2 years. So going all the way back to the original Pythagorean theorem is time wasted.
Yeah.
C is equal to that.
Yeah.
And any of the short sides, whether it's A or B, is equal to the hypotenuse squared minus the other short side squared. In other words, B would be equal to C squared minus A squared. Okay?
Yeah.
So really what I would like you to remember are those two. When you are solving for the hypotenuse, it's the square root of the sum of the other two sides squared. But when
Okay.
you're solving for one of the short sides, like number 7, then it's best if you jump directly to that, not have to go all the way back to that and solve for A.
Okay.
There's a lot of algebra involved by going back to the Pythagorean theorem and solving for A. Whereas memorizing that might seem like a waste of time, but only because you're going to have to do it 500 times. Let's get really efficient at doing it.
Okay.
So what is x equal to in number 7?
Number 7, x is equal to 38 squared minus
Hold on. Always start your answer how?
the square root of 38 squared minus 25 squared.
And what's that number?
38 squared minus 25. That would be 28.6.
28.6?
Yes, or the square root of 819.
Yeah, I actually prefer that. Square root of 890?
819.
819. Square root of 819. Good. Because we could definitely simplify the other. Now, can I simplify the square root of 819? Well, let me ask you something first of all. Does your teacher want all of your answers with radical signs or in decimal?
I think so. I think they want them to be in simplified radical form.
Okay.
Yeah.
So let's look at the square root of 819. Are there any factors of that number that are perfect square numbers? Remember, here's what your perfect square numbers are.
9.
Perfect. And you know that because the digits add up to 9. In other words, 8 plus 1 is 9, plus 9 is 18, and then 1 plus 8 is 9. If your digits add up to 9, then it is divisible by 9.
Okay.
So you can always tell, no matter how long a number is, whether it's divisible by 9. So it's definitely divisible by 9. So it looks to me like that's 91 times square root of 9, correct?
Yes.
Which is 3 root 91. Is root 91 simplifiable?
Yes, actually. No, actually, no.
No, that's a prime number. If it's a prime number, it's not simplifiable, okay? In fact, the rules for what makes a radical number simplifiable is there has to be a factor that is a perfect square. And by that, I mean the following. Is that simplifiable?
No.
Well, it's the square root of 4 times the square root of 2. That's a perfect square. So it is.
Yeah.
Is this simplifiable?
No.
No, because the only factors of that, none of them are perfect squares. 5's not a perfect square, 2 isn't a perfect square. So it's all I've done is take the square root of one number and turned it into the square root of two numbers. That's not simplified. The only way it's ever simplified is if you can pull out a whole number. You've got to be able to pull out a whole number, which means you have to find a factor that is a perfect square number. All right. We got 5 minutes. Let's do another one. I think we did everything there. Yeah, we solved for x. All right. There is a rule for triangles. And I think I should tell it to you because it's really an important one.
Yeah.
Any side, hold on, let's get so I can write. This is not that tough to remember, but extremely important. My Windows ink workspace is acting up. There we go. Here's the rule. Any side of a triangle has to be less than the sum of other two sides. And the reverse. Well, what would the reverse of that be? Has to be greater than the difference of the other two sides. If it does not satisfy that, it is not a triangle.
Okay.
For example, that one has to pass that test. Is 6 less than the sum of the other two sides?
Yeah.
Is 6 greater than the difference of the other two sides?
No, it's equal to.
Not a triangle. Number 9. So that's not a triangle. Now, 7 is less than the sum. It's greater than the difference. And we need to check all three sides. Is 15 less than the sum? Yes. Is it greater than the difference? Yes. Is 20 less than the sum? Yes. Is it greater than the difference? Yes. So that is a triangle. Okay. Now, there's the shortest side. There's the medium side. There's the long side.
Yeah, okay.
How do you tell if that is acute or obtuse?
I'm not sure.
Well, first of all, I know that angle is the smallest angle. Because the other rule about triangles is the smallest side is always opposite the smallest angle. And the largest side is always opposite the largest angle. So, what we have to do is kind of use the Pythagorean theorem here. If this angle right here was 90 degrees, then 7 squared plus 15 squared would have to be equal to 20 squared, correct?
Yeah.
If it is less, then it's an acute angle. If it is more, it's an obtuse angle. Well, what do we get? We get 49 plus, what is that? 225 equals 400. So the left side is less. That means that angle that I got double hash marks on is acute. In other words, if the left side would have been bigger than the right side, then it would be obtuse.
Okay.
Okay. Let's just do, we got 1 minute. Let's do one more here. Let's look at number 10. Okay, first let's draw a triangle. And that's absolutely an approximation. So I'm guessing that's the short side, that's the long side, that's the next shortest side. Okay. So if this was an obtuse triangle, 43 would be the long side, correct?
Yeah.
Well, if it was a right angle, then 38 squared plus 29 squared would have to be equal to 43 squared. Can you give me numbers on that? And that.
So it would have to be, so 2, that's what those are, 43 squared. 1,849, so they are not equal.
Which one is bigger?
The 38 squared plus 29 squared.
Okay. That makes that obtuse.
Okay.
In other words, in number 9, it was less, the left side. In number 10, it's greater. That's the difference between acute and obtuse. And if it's exactly equal, you have a right triangle.
Okay.
All right, let's end it there.
Okay.
Hopefully that's been a little helpful to you. And we'll pick up next time.
Okay.
All right. Have a good, let's see, this Sunday night. You start school again tomorrow, don't you? Or are you on spring break?
I'm on spring break. Yeah.
You are? Okay. Well, enjoy your spring break.
Okay. Enjoy your week.
Talk to you later.
Okay.